Hello everyone. In this problem, we're going to look at an application of angular speed and linear speed, and most importantly, the relationship between them. As we know, the two speeds are related by the formula V equals R omega, but V is the linear speed and omega is the angular speed. And this omega needs to be in radians per unit of time. Now, in this case, we're dealing with hours. So the first thing we're going to do is we're going to go ahead and take the angular speed which we're given. In this case, this bike is moving at 200, well, the wheels of the bike are moving at 205 revolutions per minute. So we're going to take that 205 revolutions per minute. So just to get an overview, we know the wheels are 13 inches. We know the revolution speed of the wheels, and we want to find the linear speed basically in miles per hour. So first we're going to take that and we're going to take it in radians per unit of time. And we want the hours, so let's take care of that right away. So we know there are 60 minutes per 1 hour, and we also want to turn the revolutions into radians. We know that 1 revolution corresponds to 2 pi radians. Now if we look at the cancellations that are possible, we notice that we can cancel revolutions with revolutions. We can cancel the minutes with minutes. And the only units that should be left now are radians and hours, which is perfect. So we'll go ahead and multiply this out. I'll leave the pi alone for now and just multiply the rest out. So I have 205, 205 times 60 times 2. So we basically get 24,600 double check that pi radians per hour. So now that we have the angular speed, we should be able to get the linear speed by basically multiplying the radius by the angular speed. Now we know that the radius is 13 inches and we have the angular speed as 24,600 pi radians per hour. Now our problem is we want miles per hour. So we're going to need a bunch of unit factors. First, we're going to go from inches to feet. We know that we have inches up here, so we're going to want inches down here. We know there are 12 inches to 1 foot. And we also are given actually up here that 5,280 feet equals 1 mile. So we're going to have 5,280 feet here corresponding to 1 mile. Okay. Now, as you know, radians are a unit that don't necessarily contribute in our computations. So they can be brought in and taken out at will. without making any difference. So we're going to ignore them for the purposes of our calculation. So here, because they're just telling you how many radii, so it's a count rather than a unit. It's a count of the number of radii. All right, so now we're basically, first of all, we notice that cancellations work out here. Feet cancel feet, and inches cancel inches. And if we look accurately and we ignore the radians, we realize we have basically miles on the top and hours on the bottom, which is exactly what we want. So the multiplication that's going to be involved on the top is going to be 13 times 24,600 times pi, and downstairs we have 12 times 5280, and the final unit should be miles per hour. And when we take care of all that, now we're basically just going to go to our calculator and we're going to type everything in. So we're going to have 13, well, let me go ahead and open a parentheses. So we're going to have 13 times 24,600 times pi. We're going to close the parentheses. Now we're going to divide, open another parentheses to contain the denominator. 12 times 5280, and we go ahead and hit enter. And if they want the answer to the nearest tenth, notice that that becomes approximately 15.9 miles per hour. So you can see the power of unit factors in making this kind of problem much easier for you to handle. So make sure that you use them properly. And that should do it until the next time we meet. Be safe.